Hello, my name is Tyler Dean, and welcome to Linear Algebra. This is our second video problem of the 3-week, and let's get into it. So today we're looking at a system of equations, and we need to describe them in various ways, such as parametric vector form, and describe them and discuss them both algebraically and geometrically. So first, as in highlight in yellow, we have our parametric vector form. As you can see, we have our matrix form with the scalars all in together, and they all equal each other. So first we have to, take our augmented matrix and augment it all the way down to our reduced echelon form. Now we can see that we have x3 is free, which allows us to solve our equation much easier. And as you can see, we have our x1, which is reduced, which equals -5 minus 4x3, x2 equals 3x plus 3, and x3 is free. Then since we knew x3 is free, we incorporated that into solving for x2 and x1. So now we have those, we put them into our scalar, or our scalar equals our equations. Then we need to separate our constants from the scalar or the equations. Then for our final parametric equation, we have x3 equals our first vector plus our other vector. To check that second part, we use SageMath-Cell, which gave us our -5, 3, and 0. And we also got the same thing. But to check the -4, 3, and 1, we have to use homogeneous AX equals 0. And homogeneous basically just means it's all equal to 0. So as you can see, we have our same matrix. They're all equal to 0. We use the same transitions. And we got the same matrix. So now we have to solve for our x's again, but with the solution set as 0. As you can see, x3 is free again, which allows us to find x1 and x2 much more easily. So x1 equals -4x3, x2 equals 3x3, and x3 is free. So our homogeneous parametric is -4, 3, and 1 with our scalar of x3. And as you can see, it's the same exact thing, which is good that we checked it. So graphically, looking at our graphs, we also used Algebra online, great website. So starting out, we have our first part that we used a calculator for, and we checked using the matrices and the parametric. So then using that, we have to solve, or not solve, but plug it in. As you can see, we have our first part and parts from the matrix, which are giving us our algebraic values that we found, which is 4, 3, and 1. But as you can see, between the different matrix or the vectors, that it's all the same sequence of numbers, but everything has different signs but they all stay in the same order. Now it's because the vectors are working together to create new vectors and shoots out from the other vectors. As you can see, our main vectors are all solid and our shootouts are all dotted lines. So it all looks pretty flat, but you can slightly tell they're all in different planes. So I had a different picture to show that they're not all in the same plane, but they're all like separate. So overall, comparing the solutions are the same, using the matrix and parametric and homogeneous. Then I think that's pretty much it. Discussed it geometrically and algebraically and showed my steps. I think that's it.